Now the next job I've got to do is to make some more replacement rocker shafts for the Morini, and just going to give the lathe a quick clean up after the commutator job. And I'm going to swap the chuck out for my multi-size collet chuck. So I really like these American long nose fittings. The chucks on this lathe are of a pretty manageable size, so I don't have any problem, even with the 9-inch four-jaw, getting them on and off. Dive down. Check up the chuck, and I'm just making sure there's no little bits of swarf in the taper you're going to interfere with the mounting. Line up the keyway, get the thread started. And these chucks take these collects, which have got 6 spring-loaded blades, so they grip quite securely. The only disadvantage is you really have to be gripping over quite a lot of the length of the blades. You can't just have something at the front. On occasions when I've really had to do that, you put a packing piece in the back to support the back of the jaw. I'm just going to check this piece of stock's the one I think it is. Yeah. Just the 12mm silver steel or drill rod for our American cousins. Little over 1% carbon with some chromium in there, so it's got a brighter colour, hence the silver moniker, and it's generally water hardening. I'm just going to face this bit of silver steel off. And break the corner, put a chamfer on it. Okay, now I've got a little bit of 1/4 inch high-speed steel ground up to cut the circlip groove, and held in this nice Eclipse tool holder. I like to use a nice stout tool bit usually, but when you're dealing with little parting tools or grooving tools like this, you don't really want to be grinding a huge, great big half-inch square bit up. And actually this is a bit I inherited pretty much ground to size. So I've got the dimensions written down somewhere, and will come in about 2.5mm. This is a non-critical dimension, so we'll come into about there. Silver steel doesn't machine all that nicely, and it has a bit of a tendency to chatter. So got a fairly small overhang here, so I'm just going to put this first groove in. Circlip groove is 0.4mm deep, so I'm taking 0.8 on the DRO as it reads out in diameter. Okay. Now I don't want to pull this bar out and cut the next circlip groove with a lot of overhang. So what I'm going to do is a little trick. If I put the cutter back into the cut, into the groove, and I will set the Z-axis on the DRO to 0 again. I'm just going to loosen the chuck up. Okay, and referring to my drawing, the next circlip groove is at 8.5mm. So I'm going to use the tool to draw the bar out of the chuck. There we go, 8.5. And tighten the chuck back up. Come clear. And wind the DRO back down to 0. And that will set this second groove 8.5mm from the first. Now if I come back out to 8.5, I can go back into that first groove, loosen the chuck up again, and the next groove 39.5. Again, tighten the chuck. Come out. DRO back down to 0. Where are we? Going the wrong way. Let's have a shot. Probably being a bit too fussy here. And just so we're confident of what we're doing, I've got an original shaft. You can see here that the oil grooves are quite broad, and they're an arc. Now it reduces the bearing area of the rocker by quite a significant proportion. Let's get up a little bit closer. So my thought was to use a narrow circlip groove as the oil groove, and it appears that Morini themselves had the same idea, because that's exactly what they've done with this. But I have to say I'm pretty unimpressed with the quality of finish on this new old stock part. But you can bring and align the circlip groove and the oil groove. You can see they're aligned, and if I align this oil groove, you can see that the groove lines up with the tool, so we're pretty confident we're in the right place and everything's working. We've just got 2 more grooves to go. Again, we come back to the 39.5, and we can put the tool back into the first circlip groove, loosen the chuck again, oops, we aren't actually in the groove there. There we go. I can pull the bar out to the final dimension. Unfortunately, I've only got the one camera, so I can't show you the DRO simultaneously. There we go. Come clear. Back down to 0. And again, I'll just bring this shaft in here, and I can do a visual check that it's going to be in the right place. Didn't have quite as tight as I should have done there, which is why it sang at the end. So that's all our circlip grooves and oil grooves done. So the next thing to do is to part off. When I find my parting tool, there it is. and I will just visually line up, come across and really eyeball this dimension at the end. Not at all critical. It's about 2.5 millimeters. A little more, a little less, wouldn't hurt at all. Now I'm running the parting tool blade upside down because it helps with chip clearance, and I'll come down in speed, make sure the chuck's good and tight. Run the lathe in reverse. Starting to go, and there we are. Move the pick from the end of the bar. Move the fag end of that bar. Touch off on the end. Go back into forward. Back into high speed. That's essentially the rocker shaft done, but the edges of the circlip groove, I've got a little bit of a burr on there, so I'm just going to go and pick up a file. I've just got a little needle file. I'm just going to use it to break the edges on these grooves. Flip it round and do the other two. And there we have one rocker shaft, and all that needs now is heat treating to harden it up as a bearing surface, and there's its mate. And we can go and make a Morini rather less clattery. They have a little bit of a reputation of being.